Hello, welcome back. For this one, I'll be showing you guys how I do external ESPs. For this, we got a few things we need to do. First, we'll need to find the view matrix so we can use DirectX roll to screen to properly position everything. We'll also need a way to differentiate between enemies like common infected, tanks, hunters, or any other weird zombie types, so we can scale their health bars and names correctly. For this, we'll also create a cheat manager class to wrap everything together so our classes can communicate. But before we do that, if you just found this video randomly, this is part of a series, so I recommend you watch the others first. Anyways, we'll find the mu matrix after we write the ESP logic, so we can just guess and check different addresses without having to worry too much about verifying them. But before that, let's just start by running our cheat manager class and getting ready for the ESP. Alright, so let's actually make that class. So let me go to here, right click, add class, cheat manager, both of these to the source so we don't get any errors. In this, we're going to need a couple includes. We're going to need memory so we can do forward declaration with, we need pointers, and we're going to need vector so we can store a reference to our entity list, which is a vector of unique pointers. In this class, we're only going to have two functions really, like I guess one, because we have the constructor and I like to call the main loop, which is going to handle calling the rest of these things. So it's going to render our menu. If we have the menu shown, it's going to handle drawing the ESP, and it's going to handle reading all those offsets for us. And we're going to have a couple of private members. Like I said before, I'm going to be using unique pointers, so I don't have to manually manage the memory of these forward declarations, which we'll need right here. We need one for the offset handler, we need one for the overlay, and we need one for the ESP, which we haven't made yet. I'll make in a second. And we need one for the entity. For each one of these, I'm just going to make a unique pointer declaration. So for the player and entities, I'm going to be storing them in the class as references to their original copies in the offset handler. So every time we read them or modify them in any way, we don't have to make a copy that could cost 1,000 bytes of copying and writing every single frame, which is going to save us a lot of time, make our ESP run a lot smoother. And I don't know what I have this display. And our vector was std vector of std shared pointers of entities, and it's a reference to entities. In here, we're going to have two functions as well. We're going to have reread pointers, which is just going to call the offset handler and update all the values. And then we're going to have a render function, which is going to call the overlay. It's going to call the ESP and draw our settings menu. Now let's set up our manager real quick. Before I do that, I do want to organize our code a little bit here. So I'm going to make a new folder. We can call it memory and just drag all these four memory handlers in there. Make a new folder and let's call it cheats, I guess. And in there we'll put the ESP and the aimbot logic or any other cheats we might add. So let's make a new class, ESP. For now, we'll just have it in there without anything. And then we'll go back and populate it. Okay. So we'll need a couple includes in here. We need the memory handler. We need the offset handler. We need the ESP. And we also need our overlay. And in here, because this class does come with references, we're going to have to declare them a bit differently. We're going to have to use what's called an init list, which is you start with the colon, you go with the variable you want to define, which usually you want to go in the same order as you define them here. So that's how we want to do the offset handler. Of course, we don't have to do all of them. We will only have to do the player and the entities because those are the only two references we would have to do this with the init list. If we're using it, we might as well do it for all of them. So you put the thing you're trying to define, you put parentheses, and then you define it like you would in an equal sign. So we just do make unique offset handler. You put a comma, and you do the same thing for all the types. So for the ESP, which I think was the second one, ESP, std, make unique, and so on. And then for the actual references, what we're going to do instead is we're going to do player is going to be equal to the offset handler, get local player, and for the entities is going to be equal to the offset handler, get entities. And that's pretty much it. Now in here, we're gonna need a couple things that we haven't defined yet. We need a way to offset our ESP because right now our menu is drawn over the whole screen. So we need to find the window position and then offset our drawing to start where the window position starts, which we haven't done yet. So let's do that real quick. We need int width, height, offset x, I guess, offset y. Let's do something like this. Let's just figure it out as we go. Offset handler, get memory handler, which we'll add real quick, and get window size, and we'll pass in those parameters. Height, offset x, offset. So I'm going to go to the offset handler real quick and add that function. There's probably a better way to do this, but that doesn't expose the memory handler class, but it would be too many functions. So we're just going to do the simple way. Memory handler, and just define that real quick. And we'll have to add this in a second. After that, we have to set the window offsets in our ESP, which I guess I'll just do now. Just remember to use these exact same names. Offsets X, offset Y, ESP. And I'm doing them in two different functions because sometimes you might want to detect when the window is resized, so you don't want to update the offset, but you still want to update the size of the window, which I'll show you guys how to do later on if we have time on this video. Width and height. So let's go to our ESP real quick and add those two functions that do absolutely nothing for now. Let me add them real quick actually. Public, private, offset Y, and then just have a setter and getter for these. Or actually just a setter. I don't think we need a getter anytime soon. So void set window sizes, and I'm just going to declare it inline and do the same thing and do an inline definition for that as well. Okay, perfect. Let's go to our cheat manager again. This should be fine now. Now in our reread pointers, I think that's the next thing we have to define. We're just going to call offset handler. Eventually we're going to add more things to this. For now it's just one function call, but we're going to add more things with other cheats that might need to be updated. And now let's do the render, which is going to be something we're going to have to update because right now if we go to our overlay, we have everything in a loop. Since we were just testing, we're going to have to separate these into three parts. We're going to have one for starting the render, which is going to set up the context with DirectX and let us start drawing so that we can start the context here, draw stuff with our cheat manager class, draw stuff with our ESP, and we can render our menu because we want the menu to be drawn after we draw the ESP because we don't want the ESP lines to be on top of our menu. That's going to be really messy. And then we want to be able to call end render, so we set up the drawings, clear the screen, and get ready for the next frame. So we already have start render, and it seems that we have everything correct here. We need render. We can simplify this a bit. If not show menu, return, and then just remove all of this and untab it. Makes it a bit nicer. And we only want to begin the ImGuide menu when the menu is open. Even if we want to use ImGuide to draw things on the screen, we don't need to begin a new frame or a new window for it, since we're drawing directly on our frame buffer. In end render, we're going to have to add one thing. We're going to do if show menu. We did show the menu, then we're going to have to end the window drawing logic, which is just done by calling ImGuide.end. Otherwise, we're going to have to call render, or either way, we're going to call render. We're going to set the device context, and we're going to set the render draw data. And we're also going to have to D3D swap chain present and just flip the buffers. Switch the current buffer with the buffer we're going to draw to on the next frame, which is the same thing we have here. We're going to have to separate this function into a handle messages function. Let's do that. Void handle messages. In here, we can just basically copy all of this, kind of. Remove all of this. That seems to be correct. We're setting a new message, storing its memory, so we clear it completely. We're going through a while loop for every single message and that message thing that we're reading here with peak message. If the message is our hotkey, which we defined up here in our register hotkey, which is our BK delete key, or whatever you set it to enable the menu. If that's the message, we're going to toggle the menu. After we handle that message, we're going to translate the message and dispatch the message to the WD rock, which is going to handle all of the Windows messages for us and send them over to IMGUI as well. We also need to add one more, which I guess I missed. If message.message is equal to WM quit. We don't really need it, I guess, but it's nice. So if our message is the quit message, which is either you right click something and you click the close window, you alt F4, something like that, your window's going to get to WM quit. If we get that, we don't have to read any of the other messages, so we can just break out of this loop and just translate it and send the message to our proc manager up here, which is just going to destroy the window and close our program. And I think that should be good. I'll probably missed something, but go back to the gmanager.cpp and let's actually do our render loop here, or our render. So before we do anything, we want to handle any messages that the client might have sent. So we handle the messages. We're going to overlay stop render. We're going to draw the ESP first. The order here does matter, because if we were to draw the menu first, our menu would get drawn and then we would draw the ESP on top of it, which would make it really messy, like I said before. So make sure you put any drawing logic before you draw the IMGUI menu. Draw ESP, what should this take? Let's make it take the player, the entities, and the offset handler, get view matrix, which we don't have yet. After that, we're going to call overlay render. So we draw the IMGUI menu, and after that we can call overlay and render. And that should be good, I think. And we go back here, we're missing any functions, the main loop of course. For now we can just do while true to test it out, and then we can switch this later. We'll have reread pointers, we call render, and we're going to sleep for 1/60, which is just giving us a frame rate of 60 frames per second, which I think should be enough. Yeah, let's just go with that. Okay, so let's actually do our ESP now. We go up here, we're going to need a constructor, we're going to need the draw ESP function we just made, which was play, reference to play. For all these functions, I'm going to be using references, so we don't have to copy over those big structures every single frame. This was an STD vector of std pointers of type entities, reference to entities, and the view matrix, which should be a float of size 16 or a 4x4. And we don't have to pass this by reference anyways, because a pointer is the size of 4 bytes. So it's going to be 4 bytes anyway if we pass it as a reference or a pointer. Since a reference is just a pointer that the compiler changes to a pointer anyways. And I don't know why I keep doing that. Void, let's do void draw settings, because we want to have each cheat draw their own settings menu. I think it's going to make it really simple, which when every class can handle its own settings or colors or anything like that. Let's do bool is enabled. We'll probably use constant return enabled. So we have these. We need bool enabled. I'm color for the enemy color. Right now we only have the entity list for the zombies, so we'll just have the enemy color. We need to include IMGUI, and we also need to include gen code. In here, in the private section, we're going to have two functions. We're going to have draw center text. This is going to be very similar to the one I used in the assault cube. You watch that one as well. But we're going to do some scaling, because in assault cube the game is really small, so you can get away with just drawing the text in any size. It's going to look pretty decent. But in Left 4 Dead 2, maps are really big, so if the enemy is really far away, we're going to have to do some scaling on the text so we can still read it, or just not draw it at all if they're really far away. So with the text, the place we're going to put it, float x2 and float y. Let's include string. We're also going to have to include a vector. It's not going to give us an error until we build, but you need a vector because you're passing a vector by reference. We also need draw scaling bar vertical. Let's take float x1, float y1. I think that's going to be a bit easier. We do it in order. Float x2, float y2, width, and vector for color, float value and float max value. This is for the health bar, and it's taking floats because even though our health is in 32s, we want to be able to do float division. So whenever we call this function, it's going to cast it for us into floats, so we can actually get a decent value instead of it being truncated to 1 or 0. We can do division with integers. Let's go ahead and do the ESP, and we also need to go back. Actually, we don't. I'm just include it in memory. Before we do that, we're going to have to add 2 source files, which I'll link to in the description. That's going to be the geom.h and geom.cpp, which you might recognize from the SawCube series if you also watch that. This one's a bit different because I've changed it a bit. Now it has 2 different functions, one for the world to screen for DirectX, one for the world to screen function for OpenGL. L4D2 uses DirectX, so we'll be using that function, of course. And let me include it real quick so I can show you open folder and file exporter. Drag this over here, just put this in source, and we can just copy and paste these over. Again, they'll be in the description. Probably put a link to it for the GitHub. You can just download it from there. Now we can just go right click, add existing item, source, add these two. If you hold control, you can add more than one at once. And there it is. So this library that you just downloaded, it's basically just a vector3 class with all the operators and functions that you might need for drawing an ESP. And like I said before, we also have the OpenGL world to screen and DirectX world to screen. The only difference between them, if you're familiar with linear algebra, is whether they use column major or row major matrices, which is basically just how you count them. So in column major, you count down. In row major, you count to the right first. So here, the order starts going down here. Here, we start counting to the right instead. But basically, we're just multiplying our position to that view matrix that the game calculates and use that to convert our world coordinates to screen coordinates. Because this is just math, we could just calculate our view matrix ourselves, but it's a lot of work. So it's usually easier just to find the game's view matrix. Hopefully it doesn't come to that, because that will be a video and a half of math. So anyways, let me go back to our generated code, delete that. Instead, just include geom.h for that vector. Perfect. Anyways, let me go back to our ESP, and we still have to do our constructor before I forget and we get errors later, which is literally just going to be one thing. Let me use the init list with this so you guys get another look at how you could use it. So player color, or actually not player color, enemy color, it's going to be equal to new I'm color. Let's make it 0. Actually, we want it red, so 255, 0, 0, and the alpha value 255, so it's not transparent at all. And because we're using MGUI colors, we need to include //MGUI.h. Okay, back to the ESP. So if the ESP isn't enabled, we can return. Now we're going to iterate through all the entities. So we're going to use autos for this, and we're going to be using auto reference. Make sure you use a reference here. Auto reference entity in entities. And we're using a reference here because if we were to use this, it's going to make a copy every single time. So it's going to make us have or own a new copy of that shared pointer. If you were using unique pointers here instead, we would get an error because you can't copy over unique pointers. But we don't want to make a copy of a shared pointer and claim ownership every single time we iterate through this loop, so we're going to make a reference instead. So if entity health is less than or equal to 0, we're going to continue. They might be in the entity list even after they die for a couple frames. So we want to make sure we don't draw them on the screen. Let me go back here because I don't remember what I called the position. We don't have position. Okay, I guess we're finding the view matrix now because I don't have position. All right, there we go. I set up a little server real quick. I set SP sheets to 1 and set nbstat to 1 so enemies don't attack me. They're just frozen. Makes it a bit easier to test everything out. Okay, so first thing we want to figure out is where the hell is our position, and does our player class match up with the entity class, because they might not. So let me reattach, and this is us, and this is the entity list. So let me take a random zombie from here. And this entity list does include physics props, which is weird, but that could be cool for the ESP. Anyways, let me choose infected. Go to a class instance. I guess I can copy this address. Why is this a pointer to an instance? Put that in one of these. And let's add some bytes. And let's see if it matches up. So somewhere in here we should see the position, which seems to be these three. And the vector 3, which already doesn't match with ours, so we're gonna have to split up our position. Our head position is not 0, 0. I don't know why it's all the way up here. This is 88, so it's down here. Their health is 50. From I remember, is it that guy? It's not that guy. So this has to be the flag, because it matches up with the other one. Flags, and I'm guessing one of these is max health, the other is the actual health. So that's good to know. Health and max health, I guess. Okay, so let's call this in position. And if I remember correctly, positions in Source Engine are not the head position or the foot position. They're the center of the body. So in this case, it would be something like torso. Just leave it as position for now. But that's going to come into play when we actually do the ESP. We're going to have to estimate how tall they are, which I'll do real quick actually. Let me load clip out of this because I'm stuck. And one way you can estimate how tall you are is just by jumping. So let me go my entity. My position is -157. I jump, that's 123. It's like 20 something. And that seems to be half of my body. So we'll do add to the torso 20 to get the head position, and we'll subtract 20 to get the foot position. Anyways, that's not the point. Let me update our offsets. It's going to be a pain now because we're going to have to update all of these to actually use the player like I was mistyping earlier. Let's generate a code, paste this, and where's our... Actually, this would be the player class now, and this tiny one, actual entity. So we're going to have to change a couple things. Up here, this is going to be a player now, and here, this is going to be a player, player, and I need to fix the include. That's why it didn't work. And we're going to have to forward declare this up here as well. Let me go to the cheat manager. We're also going to have to update all of this to be a player, add a new one. Anything else here that takes... I think that might be it for now. I guess we'll figure it out later. And since we have the max health, or hopefully that's what it is, we can use that to get the entity type by just looking at the wiki and checking their max health and seeing which one it corresponds to. I'll probably add that in a second, but let's try to find the view matrix. So usually in games, the view matrix is stored in 4x4 matrix, and one of those members is going to be your orientation. Orientation meaning where your camera is looking, so like your yaw and your pitch. There are two ways the game can store your yaw. It could either be stored in radians or degrees. Usually it's radians, but some games also use degrees. I think Saw Cube used degrees, if I remember correctly. So that's going to be a float, and we're going to scan for exact value. Now I'm going to assume the range is going to be from looking straight up, it's going to be 1, which is 1 in radians, and -1 is going to be looking down. Some games might use different ranges, like this might be 1 and this might be 0, depending on how they scale it. And if they're using degrees, this would be a 180 and 0, or 90 and -90, or something like that. So make sure to scan accordingly if you don't find one or the other. Just try all of the combinations that you can think of for storing radians or degrees. Whoops, let me look straight up. Scan for 1, -1, 1, and pause so it doesn't make me shoot every single time. Hopefully we should get some static pointers somewhere in here. Sometimes if we get lucky, we'll see static pointers, which means one of these is bound to be correct. Now how do we verify that and go from there? One way you guys to test it out is go to the memory view, Right click, browse this memory region, right click this, display as floats, and if it's correct, the view matrix shouldn't be moving if you're not moving. What this means is the view matrix shouldn't be recalculated if your camera isn't moving. So if you see that it's constantly changing, it's not being calculated from your camera's position, so it's either some other matrix like the projection matrix or the object matrix or whatever, and it's up here. And it should be a 4x4. So if we look here, maybe move this to the side, we have 1, 2, 3, 4, 5, 6, 7, I guess 8. That one value in the middle doesn't seem to be moving too much, even though we're moving a lot, so it's probably not this view matrix. We want it to, all of it to be moving when we're moving, because we're recalculating it from a completely different position. So it's not this one. Anyways, we're not going to do all of this, do all of those. We're just going to test them out once we finish the ESP. So let's do that real quick, and then we'll update our memory handler, use that address. Okay, so we have to get the head position now. And like I said before, source games use torso position. So we're gonna have to do some assumptions here, or make some assumptions here. All the entities are the same size, which is not correct. Eventually I might do bones, but we'll see. If you guys want bones, I can do bones, but it's just a pain. So if you guys are fine with boxes, I'll do boxes for now. Let's do 20. Let's assume our head is 20 pixels or 20 units or whatever this is above our torso. And let's make foot position be, I guess, 40 pixels. Most people's legs are longer than the torso, so let's go with that. I guess I can always change it. Then we're gonna get the head screen position, which is vector 3. Head screen position is equal to direct x world to screen, which takes the head position, the view matrix, the window width, and the window height. And we're just gonna copy this and change it to foot. Actually, this would be feet. What am I saying? Okay. Now we're gonna offset everything by that offset that we got earlier, which is basically changing or offsetting everything from the top left of our screen to where our game is actually being drawn. So head screen position dot y plus equals offset dot y. If you don't do this, even though your game's in the center, all your ESP logic or ESP drawings are going to be drawn as if your game was in the top left corner of the screen. And we're using the window height and window width to actually calculate or convert those world positions to screen positions. Okay, so plus equal offset y, and let me do the other two. So now we're going to check if the feet screen position or the head screen position either works is less than 0 or the head screen position is less than 0. We're going to continue. What this is basically checking is that if the z value, which is in screen coordinates, is basically the depth. If the depth of the drawing is behind the screen, then that means it shouldn't be visible, so we don't draw it at all. After that, we're going to get the height of the player we're drawing, which should be the absolute value of head screen position dot y minus foot screen position dot y. And the width, I'm going to assume, is going to be height over 4, which is how, I guess, how thick the person is. I don't know how else to put it. And now we're going to set the top left of the ESP box, feet screen position dot x minus the width. This is the left side, so we want to subtract the width. The screen position dot y, and we're using over 4 because the width should be height over 2. But since we want to go half of that distance to the left and half the distance to the right to get width. Otherwise, we would have to do minus width over 2 and plus width over 2 on the top right. Instead, we divide by 4, so we can just do minus width. Hopefully that makes sense. I'm going to do the same thing for the top right. And then I'm going to do the same thing for bottom right, which is going to take the feet screen position plus the width and the feet screen position dot y. Okay, now that we have that, we're going to draw that rectangle for the ESP box. There's going to be get background draw list. We're going to add quad, which is a rectangle basically, as top left, bottom left, bottom right, top right. And of course, the color is going to be dereferenced enemy color because it's a pointer. And thickness, we can just do 1. So we can just leave it as it is. And then we're going to draw the center text, which is going to be the name of the entity, which I haven't done yet, but we will do in a second. Entity get, yeah, let's call it get entity name. I'll add that function real quick and I guess browse the wiki for all the max health values. Bottom left dot x, bottom right dot x, and feet screen position dot y plus 5. We'll do 5 for now, and we're adding 5 because we want it to be below our box. Remember, plus in screen positions is down. We start 0, 0 here, and then as you increase the y, you go down. And then x is just normal. X is just, as you add it, it goes to the right, but y goes down. We go to our generated code. And because this isn't an internal, we can have our own functions in here with no problem. So I should be able to do std string get entity name. But the one thing we can't do, because of how we're copying entities right now, is store values inside of this. Since every frame this is being copied directly from the game, all of this, if we store any variables in here, it's going to get overwritten. So as it stands, we can only have functions in here. But later on, if we need more performance or we need to store things in the entity list itself, or the entities themselves, then we'll have to change how we're writing and reading from the game. Basically, I'm going to do a switch statement on their max health, which is what I called it, right? And this is in the wrong place. And I'll have to look up the wiki for the rest. I'll be back. All right, so here we are. I was able to narrow down some of them, but some like the hunter and smoker share HP values. So I just did hunter / smoker. And there's a couple different zombies that have 50 HP, so I just called them common infected. And this is all assuming the game is a medium difficulty, because if you increase the difficulty, it goes up even higher. So we would have to have another switch statement. But for now, until we find some sort of class ID or something else we can go off, this is a good workaround for that. Okay, let's go back to the ESP. Now we want to draw the scaling health bar, which we haven't defined yet. Vertical, I like the vertical line a bit better than horizontal bar under the player. It's gonna look exactly like this all cube one if you've done that one, but I'm gonna scale it a bit differently here because distance plays a big part in this game compared to a saw cube where the maps are really small. So bottom left dot x minus 5 minus width over 2, bottom left dot y, bottom left minus 5, top right dot y. The width, we'll just have it as 1 for now. The color, we can pass an I'm vector 4, which is just a compressed I'm color. But instead of using 255 to 255, you can just do integers instead. So we can have 0, red, green would be 1, 1 being 255 in this case, 0, 1. This is another way of normalizing colors. So instead of scaling from 0 to 255, it's scaled from 0 to 1. I could also just put 255 here if I wanted to as a float, and it would work. Anyways, entity health, I think that's everything. Yep. Okay, let's do those functions real quick. Draw center text is, I think, the longer one, so let's do that one first. So since we want to scale this according to the distance, we're going to have to do a couple of calculations. First, we're going to get the available width. How much space do we have to draw that text according to their distance? Available width is equal to x2 minus x1. We're going to calculate the default text size from ImGui, which is going to be stored in an I'm vector 2. We're going to call that text size is equal to ImGui.calculate text size. This is basically going to tell us how many pixels would it take with the default font to draw that text that we passed in. So if text size .x is smaller than equal to 0, in case there's an ImGui error, then we're just going to return. We're going to get the scale factor of that, which would be float scale factor, or how much we want to scale the text by depending on the available width. It's going to be equal to available width over text size .x. If scale factor is equal to 0, Now, since this is a float, you can't really test if it's equal to 0. What this is doing is really checking if it's almost 0, then it might as well not be visible, and we can just return. Now we're going to check if the scale factor is somehow negative, because we messed up the order of operations here with x2 minus x1 or the parameters. Then we're just going to flip the sign. So if scale factor is less than 0, we're going to multiply it times -1, since a negative times a negative is always a positive. Then we're going to cap it out. So scale factor is equal to STD max of 0.01 in scale factor. And I think we need to include for that, I think it's algorithm. Yep, we need to put 0.01f, so it types that as a float and not as a double. And we're setting the scale factor after we check that it's not too small, because if it's too small, we shouldn't be trying to force it to draw something that's going to be way too big for how far away it is. Now that we have that, we're going to check if the text size dot y, which is basically the font size, times the scale factor is less than 6. So if the font size is less than 6, which is just unreadable, really, we're just going to return, and then we can just actually draw the thing. So we're going to push font, imgui font. We're going to set window font scale to the scale factor. We're going to calculate the text width, which is the text size dot x times the scale factor. Text size dot x being the original size that imgui calculated with its default font, times the scale factor that we're changing depending on the distance. Now we're going to get the center position of the text, which is going to be x1, it's x2 over 2. Now we're going to draw the text centered on that position. Background drawless, add text, vector 2, center, minus text width over 2, y. Now it's asking for the color as an IMU32, which is, it's weird how imgui asks for colors in different ways and different functions. But I guess let's do 255, 255, 255, 255, which is just black. And you can also make this a setting if you want, but I think black just works in every situation here. But if you wanted to make a setting for it, go ahead. After we draw it, we want to make sure we set the font's size back to normal, because otherwise it's going to mess up our menu. So set window font scale back to 1, sure it's a float, and pop the font since we finished using it. Perfect. Now that we have that, we can do the other one, which is the scaling bar, which is infinitely easier. We're going to float width difference is equal to x2 minus x1, height difference equals y2 minus y1. Now we're going to have this sanity check real quick, which is just setting the value equal to the STD minimum of value and max value. So if our assumption that max health was that second value is incorrect, it's not going to make the scale really big if the value is bigger than the max value. And it's not going to give us like a massive health bar that covers the whole screen. It's always going to, at most, have a scale of 1, which is just the whole HP bar being green. Now we're going to calculate that scaled height equal to the height difference times the value over the max value. And if you chose to use N32s here instead, what you have to do for this to work is to cast either one of these to a float, so it would still return a float division. But since we made a function that takes floats, it's going to cast it for us into a float and return an actual value we can use. So now we're going to add a rectangle. Let me just copy and paste this from up here. And it's going to be im vector 2 of x2, y2. It's asking for another IM32 color, which we can just copy this. But the color is going to be actually black, because this is just the outline. 0, 0 in the width, which we're passing into the function. And now we're actually going to fill in that rectangle based on the HP and the scale value we got. So we're going to do the same thing, add rect, but instead it's going to be filled. And we can copy the same parameters as before. Instead, we're going to have x1, y1, x2, Instead of y2, we're gonna have y1 plus scaled height, and MUI get color U32 of that color we passed in, and it doesn't take a width. And there we go. We go to ESP. Let's have the draw settings tab, which for now is gonna be super simple because I don't want this video to be too long, like it probably already is. Enable ESP, an address to that enabled, so the button itself changes the value. We're going to have MUI color edit 4, so they can also control the alpha value. If you do 3, they won't be able to control the transparency. Later on, we can do this for each zombie type, but for now, something simple. And we need to cast that to a float pointer. We go to Cheat Manager real quick and make sure we draw the ESP. And there needs to be a player as well. There we go. Go back here. Now we can do if overlay dot is menu visible. If we're drawing the menu, then we should draw the settings menu for the ESP. Now we need to go to our offset handler and make sure we read the view matrix. So float view matrix 16, and I guess noticed before that were all static pointers to the engine base, so we're gonna have to get that as well. And a getter for the view matrix. And before we can test out a bunch of view matrices and see if they work, we need to make sure we calculate that offset from the window handle, which we don't have yet. So let's go to the memory handler and add 2 functions. And here we're going to need a way of reading arrays from memory, and we're going to need a way of getting the window size for that offset in our ESP. So let's make a new template. This one's going to be really simple. std uint 32t, the address, the t pointer to an array, and the size t, or how many elements that array has. Oops, here we are. We're going to, it's going to be very similar to our read memory function. It's going to be size t bytes read. We're going to read process memory, whoops, to that process handle, reinterpret cast to that weird pointer that windows the array or where we're writing to, the size, which is the size of t. So if it's an integer, it would be 4 bytes times the count. So if we're reading an array of 4 times 4 is 16, so we need to read 16 bytes in total to fill that array up. And the address of bytes read. And we just return bytes read is equal to size of t times count. Very simple function. And then we need this last function, which is void get window size. And we were passing by reference, so let's make sure we do that again. And we're going to need a new private member, which is going to be HWND, not to be confused with handle, which is HANDLE. This is HWND. The difference being this is a handle to a process, and this is the handle to the window, which is really confusing by Windows, but I guess. In here, we're going to make a new rectangle, Windows rectangle. We're going to get the window rectangle with that window handle we don't have yet. Get window rect, the window handle, and the address of that rectangle we made. If successful, we're going to set the width equal to the rect.right. So this just returns a rectangle where the window actually is, the size of the window as well. So the width would be rect.right minus rect.left. The height would be rect.bottom minus rect.top, and so on. So offset x would just be rect.left, and offset y is equal to rect. Otherwise, if we don't get it successfully, we're just not going to change any values and just return. And we do need one more function. I lied. It's to get that window handle, which I just realized is a pain. Void get window handle. Sometimes Windows handles are the same as the proc handle. For example, in our overlay, the window handle we make is owned by the process itself. It's somewhere in here where the window handle is equal to the module handle, which means it's the window handle is equal to the process handle. But not all games do that, so we're going to have to get that separately. Some games, like SLCube, share the window handle and process handle, but most of the time they don't, so we're going to have to make this function real quick. And we're going to make a new structure here. which is weird, but this is the easiest way to make this function work without having 20 different functions. We call it struct enum windows data. It's going to have a dword and hwnd. We're going to make a new structure of that called data. Data.process ID is going to be equal to the process ID of that game, and data.found window is equal to null pointer by default. Now we're going to make a lambda function, which is basically an inline function. Enum windows, or this windows function usually takes a callback function, but instead we're going to use a lambda function, so we can do it in place without having to have another function outside. It's going to be a bit more clear. Since it's a lambda, you start with this. Then you pass the parameters, which are hwnd, window, and lparam, and the type that it returns, which is a bool. And then we actually start the function. So normally, every time enum windows finds a new window, it would call that callback function, and you would handle that window accordingly. But what we're doing here instead is that instead of having an external function, we're just defining it inside the function of enum windows instead. So enum windows data pointer to pdata is equal to reinterpret as enum windows data pointer to lparam. Lparam being the custom data pointer that you can pass in to Windows functions. In this case, we made our own structure so we can pass in 2 parameters instead of the one that Windows allocates for you. We're going to set the dword window process ID is equal to 0, window thread process ID, there it is, window, and the address of that window process. If the window process ID that we got is equal to pdata.process ID, then that means we found the window handle we're looking for through all the windows in our system. If that's the case, we're going to set pdata.found window to that window, and we're going to return false, which basically tells this function that's iterating through all the windows to stop looking and stop iterating. Otherwise, we're going to return true, which means keep iterating through the functions or through the windows, and pass in the lparam that we didn't pass, address of data. There we go. Okay. Now, if not found window, we can return. Otherwise, if we did find a window, then we can set the window handle to data.found window. And I think that's pretty much it. Unless I messed something up, which is highly probable. All we have to do is set up the view matrix and test all of those out, which is really easy. And of course, I forgot to do this again. And this is a player as well. Whoops, that is not a player. And this should return a reference and not a copy because it's a unique pointer. And and we need to return the dereference memory handler. And let's add the engine base real quick. There we go. Okay, now let's find that view matrix. So what we want to do, we already passed in all these static addresses, which we're assuming one of them is correct because view matrices are usually in a static address. And this one doesn't seem correct. That one's negative or very small. So that one's not correct. We said this one wasn't correct, but let's see what it looks like when we actually build it. So we're going to take this address, engine DLL plus whatever that is. Again, you define view matrix 0x. Make sure you put 0x so it's defined as a hex value and not an integer. And in here we can just have memory handler read array. The type is a float. It's going to be the engine base plus the view matrix offset. We're going to write it to the view matrix, and the size of that array is 16. And actually we need to change our main. For that, our main has none of this. We still need these 2 includes, and we also need memory handler. It needs the ESP cheats / ESP.h, and it also needs, so now we can have cheat manager, hopefully I didn't forget anything, cheat manager dot main loop, and I guess return 0. I got a couple errors, one of them being missing an include here for memory. The other was putting an extra IMUI end here for no reason, even though we have it down here. And the other one was putting an extra IMUI end here that was throwing me errors. And I messed up here. I have a while loop and some while loop. This should not be here, because we are just stuck in this perpetual while loop. The while loop should be here instead, while peak message. So while we still have messages in the queue, we're going to read them, not just keep peeking messages until we don't have a quit message. I'm just looking through all the code now because I have a couple typos. This should be a minus as well. And we probably want to have the ESP enabled by default. We never called get window handle. We need to put that in the constructor after we attach. Alright, so it actually runs this time. And here we go. With that one we tested, or the B matrix we tested, does not work. And let's try another offset. Actually, I want to try something else. I'm going to see what accesses this address. Sometimes you get lucky with this, and stop that. These all seem to point to a float that starts at EAX plus 8. So EAX could be the address we're looking for, which is just a flat address. And that's going to be, so what I'm going to do, turn that into an int32 and just read it directly. So just open the calculator, put the X value in, copy this decimal, and just put that in there. And let's see if that works. Oh, we have one. I mean, it's drawn correctly. The name isn't. That debug window is just IMGUI when it detects you're using a debugger. It's not the actual menu. So that's not it. We check this fourth one. EAX plus 28. EAX. Try this one because this one looks a bit different. We have 59 BA224. This is completely different than the other one, so hopefully this one's paste that in there. Move all the commas. I wish you could paste it without the commas, or copy it without the commas. And let's see how that looks. Ooh, that seems to be it. Perfect. And the names don't get displayed for things that are really far away, which is good. Both bars seem to scale correctly, and we ran into an error, which is great. The error was assertion scale, scale is bigger than 0. So we messed up with our checking on the scale, which gave us a runtime error by MGUI. Okay, now let's find a pointer to that thing. It's in here. Add address manually, move that. Oops. Delete the rest of these. Pointer scan for this address. It's going to be a 1 because all these are static pointers. So this one should be a pretty simple pointer 2 as well. I'll wait for that to scan. Alright, so we have 2 pointers here. I guess 3, but we know it's an engine DLL. We have 2 pointers which point to the same thing, but one's smaller than the other. Usually, just go for the smaller one. The one bigger is usually just not as consistent. So I'm going to use that one. So we're going to copy this, go to our offset handler, put that in there, 0x. In here, we can just have something a bit different. We're going to have to read it a couple times. So uint32t u matrix pointer is equal to memory handler dot read memory uint32t engine base, and then in here I'm gonna read the B matrix pointer plus that weird offset that's in here as well, which is 2u4. If we did it correctly, it should still point to the same place, and we should have a static pointer. Search and scale failed, messed up again. And the issue being I put equal equals for absolutely no reason, so it never got scaled down. Alright, there we go. There's a slight issue we're gonna have to fix later, which is that they're still drawn even though they're not on my screen, which I guess you could call a feature, depending on how you look at it. But that's something we can definitely work on to fix in a different video. You can see the scale actually works now. If they're too far away, it doesn't show their name. And when they get close, we start drawing what they actually are. And their HP bar is actually scaling, which means the max health was actually what it was, which I'm really glad, at least for my sanity. One thing we can do is change the color of the enemies based on their type. That could be something we could do. And if you guys want, I can also do a bone ESP. That's going to be a bit harder without the SDK. And the menu, of course, still works, so should be able to change it dynamically. Perfect. And that's the weird ass MGUI debug menu that comes on when you're debugging sometimes, which is really annoying. I don't know how to disable it. Anyways, that's going to be it for today's video. Hope you enjoyed or learned something at least. Well, give me any suggestions for other things I could implement besides the aimbot, of course, which I'll be doing next video probably. Anyways, peace.